So this is going to be a few examples with different operations and scientific notation. So the first thing I'm going to review, and this is just a review for the test that we have, or the quiz rather, that we have on Tuesday. I'm going to just do a few examples, and if you have other questions, reach out to me. First thing I want to do when I'm adding numbers in scientific notation, I want to make sure that both of my exponents and my powers of 10 are going to be the same. Right now, they aren't. One is 6 and one is 5. So I need to change one of them so that they are the same. The one that I always like to change is the one that is larger if it's a positive number. So I'm going to break that down. And I know that in order for me to get them to be the same, one of my exponents have to be 5. So I'm going to already know that this one on the outer side is going to be 10 to the fifth power. And I know that 10 to the fifth power times 10 to the first power is going to give me 10 to the sixth power. And you want to make sure that those are always the same. After I have broken that down, I'm sorry, I wrote 10 to the sixth power, I meant 10 to the first power. Sorry about that. After I have broken those things down, I want to bring my coefficient directly down. So I have 5.35, and excuse my voice, I lost my voice from back to school night. Let me put some parentheses around that. Because this is already in parentheses, I'm going to simplify this expression. And I know that because this exponent is 1, I'm going to move my decimal to the right one time. And my new coefficient is going to be 53.5. And I'm going to still have that 10 to the fifth power. Now that this 10 to the fifth power matches this 10 to the fifth power, I can go ahead and add these two numbers. And I'm going to make sure I line my decimals up. Ten to the fifth power remains my power of 10. And then I go ahead and add these. 5 plus 2 is 7. Bring down my decimal. 3 plus 1 is 4. 54.7 times 10 to the fifth power. I can take this one step further by putting it back in scientific notation. And what that means is I will move my decimal over one time. So it will become 5.47. And then because I moved it over one time, I need to add 1 to that 5. So it will be times 10 to the sixth power. And that's it. There's our answer. Now let's try an example with subtracting. Now I use negative numbers for subtracting because I know some people are confused about what happens with the negative numbers. So what number I'm going to choose to break down. So when it is the positive exponents, I like to break down the larger number, but when it's a negative exponent, I like to break down the smaller number. So I'm going to break down negative 6, 10 to the negative sixth power. And I know that one of these is going to be 10 to the negative fifth power. Negative 5 plus what is going to give me negative 6? Now that's going to be 10 to the negative first power. Negative 5 plus negative 1 is going to still remain negative 6. Then I'm going to bring down my coefficient just like before. 7.9 times 10 to the negative first. And now I have 7.9 times 10 to the negative first times 10 to the negative fifth power. Because this is a negative exponent, I know that instead of moving my decimal to the right, I'm going to move it to the left one time because it's a negative 1 exponent. My new answer is going to be 0.79 times 10 to the negative fifth power. Now that I have that, I can go back to that first coefficient and subtract. So because this is the number that comes first, I'm going to go ahead and write that out on top. Minus 0.79. And being careful to make sure I line the decimals up. This is going to stay the same, so it's still going to be times 10 to the negative fifth power. And then I'm going to subtract these. I have to borrow from the 4. The 4 becomes a 3. 1 becomes 11. 11 minus is going to be 2. I can't subtract 7 from 3. I'm going to borrow from 8. 8 becomes a 7. 13 minus 7 is going to be 6. Let me bring down my decimal point. And 7 minus nothing is going to be 7. This is my answer. Unlike the other answer, this is already in scientific notation because there's already only one number in front of the decimal. Adding and subtracting is the easier things to do when you're working with adding and subtracting is the more difficult things to do when you're working with scientific notation. Multiplying and dividing are the easier things to do. So first thing I want to do is go ahead and factor out my exponents, my powers of 10. And I already know from the first law of exponents that if the base is the same, the only thing that I have to do if I'm multiplying is add the exponents and keep the base the same. So I know that what I'm going to end up with is 10 to the 8 plus 6 power, or 10 to the 14th power. And I'm going to leave that there. After I have that, all I have to do is go in and multiply my coefficients, which is 4.30 times 2.0. And I'm done. Now, if you wanted to multiply these out, that's perfectly fine. Your answer would be 8.6. That's these two numbers multiplied together. 8.6 times 10 to the 14th power. That's it. Dividing is also very similar, as in it is very easy. Whenever I have division that looks like this, I automatically want to turn it into a fraction. So I'm going to turn that into 7.8 times 10 to the third divided by 1.2 times 10 to the fourth.